Hello, welcome to this video on fast ways to design ribs for wings. So we're starting off with a design for one of the ribs in one position along the span. And because this wing here tapers, you might have some washout, you might even have a blended airfoil from one end to the other. In this case, these ribs are referring to a OML, like a surface. In some cases, you can also be making ribs that refer to wireframe, like a planform. And along the span, each rib is going to have a different size and position, but the features are pretty much the same. So we want to create essentially copies, but independent copies along the span of the wing. So that's what we're going to cover with this example aircraft here. And at the end of the video, what we end up with is, we'll unhide the parts. So we copied in two extra external ribs and two extra ribs internal to the wing box structure. And each of them is the right size along the planform and position. But they're independent of each other, but they were created in a way that we didn't have to design them from scratch. We sort of copy them and update them in their new context. So we're going to cover that for copying in independent ribs. These are parts. And another thing we'll cover is copying in assembly ribs. So if we have subassemblies of ribs, in this case we have an assembly of each rib as sort of a collection of parts that form up the rib. And these subassemblies, in this case, are mated onto a wireframe planform, so just some geometric washout. And that will be the second thing that we cover, is a way to have sort of an initial design for a subassembly and then copy in several more subassemblies, these ribs, and have them update their size according to where we place them on the assembly level geometry, which is the planform in this case. And for these parts, for this case, it's the surface OML. So that's what we'll cover, and I hope you all learned something and enjoy watching. Alright, so we're going to start off in the wing subassembly, where for now we have one internal rib for the wing box and one external rib. So we want to create some more of those, so let's open the wing subassembly. And we can see we have a layout sketch where this is going to be determine where our ribs are going to be. So for now, for this tutorial, we want to put in two more ribs, internal ones and two external ones in the same wingspan. So let's first see the slow way to do that. So that would involve first, so we'll insert a new part, we'll float it, and let's mate it in position. So the top will go to here. The front, we'll use this one. And then the right one, the right plane, I'm going to put at the point for the layout for the position along the span. So then it's constrained, so let's rename it. call this B. So that's the second version of this one. We're going to recreate this one in this position. So this is still a virtual part, so let's just also save it in an external file. So that works. So now we can start recreating this. So we'll edit it, and then in this plane we're going to take in the external references, which will be the wing skins. So I'm going to take the inner surface of the wing skins, and then also just the entire part for each of the angles. And then we can do an intersection. So there we've got the intersection. Then at that point I find it easier to work in the actual part itself. And this, I like to only have one sketch that brings in the external references. So we can call this at the top, external references. Then we can create the part from using referencing to these external references. So something like this. Can make these, for instance, collinear, and then create those radii. And so what that's going to look like for here, if we take a look at this one, so that looks like a base flange sketch. So if we look at the external references, we have the external references, then the base flange is referencing points in that external reference sketch. And then that's turned into a sheet metal base flange, then just the edge flanges. So these are separate because the top ones come in at like 91 degrees for the taper, like the vertical taper, and the front one is 90 degrees for the front spar. Then the back one is to a surface a tiny bit more than 3 degrees for that aft spar taper that we see from the top here, this taper here. So then this this flanged hole is from a form tool, so that's in sheet metal forming tool from the library here, which is a forming tool that we did in another video, the first or second video in the top-down assembly series. So that would be the slow way to generate these ribs. But we notice, so I mean, every single one of these ribs has essentially the same features, just a different, the external references to the skins are just a slightly different size. So there is a faster way to do this. There's probably multiple faster ways to do this, but we're going to check out something called copy with mates now, and make independent. So because each of these parts are different, one way to keep them different is to have them independent. So let's say we delete this part, and let's do a faster way to generate 2 more internal ribs and 2 more external ribs. So if we take this first internal rib, what we can do is in insert components, we have this option copy with mates. So there are 3 mates. We're going to repeat, this is the top plane mate, so we repeat that one. This one is, we can see this point is purple. This one is the one that's going to be different every time. So this, we're not going to repeat the same point. We're going to use a different point for the first copy. The third one, this is the front plane to front plane. So this is going to repeat. So that puts one in position. And so then if we just press OK for that one, another one's going to come in and it knows that these 2 are repeating. So the only new mate is going to be another point. So we put that one in, and that's another internal rib, exactly the same as this internal rib, copied into place. So then if we just press OK, another one's going to start to come in, but let's just do 2 for now. So if we press X, just those first 2 have been copied in. So notice they're exactly the same part. They're instance 1, instance 2, instance 3. So we do need them to be different. Right now you can see this one's too big, that one's too big. So what we can do is, let's go and make this independent. So we save it as B, this will be example. This one we can also make independent as C. And we see now that these ribs have this question mark for out of context because they don't know anymore. The references are not pointing to a good context to give them the information about what size they have to be. So we're also going to copy with mates the external ribs. So that would be this one here. So let's copy with mates these ones. This is repeated. Right plane, that's the points. So let's make sure to hide these ones that we just created. This is repeated to this point. Or sorry, not repeated. And the front plane is repeated. So that's the first one. Second one, just the point. It's going to be here. All right, so we could keep going like that if we're making even like a dozen or whatever. And then we're not going to make any more than that though. We'll do just 2 extras. So, and those ones, obviously they're too big also. So let's do the make independent part. We'll call this B. Call this elemental C. Oops. Okay, it'll be V for now. So these are similar in that if we take a look, so they have a single external reference sketch at the top, and all we need to bring in is the top surface of the top wing skin, the intersect, bottom surface of the bottom wing skin, intersect, and the intersections of the OML. And that's enough to start sketching out all the features we need with reference to the OML and also the square cut that we're going to need for the rib to slide onto the wing box. So after that external reference sketch, there's a progression of sketches where there's first an offset, then a projection of that offset and a corner trim, then these lines for positioning the sort of diagonal strut portion of the web of the rib, then the width of that, and then sort of each individual segment. And no fillets yet, these are all angular features. And then finally the extrude is just a projection of each of those portions of each of the previous sketches. The fillets are done on the actual extrude feature itself at the end. So we have now our 3 external ribs, and they're copies, they're identical. And the first one is in context. The second 2 we can see they're out of context. They have this question mark here. Same with the internal wing box ribs. We have these 3 with the first that's in context and the second 2 out of context. So let's take a look at, if we take a look at the first one here, the first copy of the external rib that's out of context. If we edit it, the only portion that's out of context is this external reference sketch. And if we go into it, we can see it's referring to things that are sort of previous memory of where it was at. So these are too far away from how the tapered wing box is smaller at this point. It's not as wide as it was at this point. So these are out of context relations if we display them. So let's select them all. So there's question marks through all of them. So let's just roll back the part to the external references portion. And let's delete the out of context relations, which is all of them. So delete them, and then we can move this to the side. And let's just take in new references that are in context in this portion. So what that would be is the top and bottom wing skins and the OML. If we intersect that, there we've got the new references that are the new entities that are in context. But the thing is, our part is still going to try to be generated by these old entities over here, which they're no longer out of context. If we exit this sketch, they are no longer out of context, but they're unconstrained here. And our part is going to try to be generated. If we take a look at this sketch, it's trying to be generated by these old entities. So what we can do is go in here and just start replacing them with the new ones that are the ones we want. Let's replace those. That should be good. Now we have in context and fully constrained here. And if we go further down, we rebuild our part in the right position and the right shape for where it's at. So now if we save, so what we ended up with here is two independent ribs. They've got different names. They're both in context and independent, so that's what we want. So for the internal wing box ribs, I just did these two here to show you all. It's the same process, but with these internal ribs there's a lot more features, like little entities and all that. So there's a few tips to make it easier. So I'll just add in a fourth one. So I put in a fourth point here, and we'll add in a fourth internal rib, and we'll just see a couple of tips on how to do that same process as the external ribs, but for a part with a little more features going on. So we're going to copy with mates. This is repeated. This one is the point. This is repeated. So we have the second instance of the A, which is too big. So we make it independent. So let's just say it's, let's just call it D example. And so it's out of context. So what we do here is go into the external references, and like the other one, we're going to delete all of the out of context relations and move it over. And this one, it's got the cross section of the 4 wing skins, or the 4 wing box skins, and the 4 angles, the caps. So we'll select those from the tree and do intersection curve. And for this one, at this point, there's a lot going on compared to the external rib. So I'll finish it in its actual part so that we don't see the rest of the assembly. So what we've got is we're going to need to replace entities for the part to move into its new references, like the other, like the external ribs. But here we can see there's a lot more going on. There's ones that overlap. So there's a few tricks for this. So the first trick I would say is when you're selecting these entities, so if you select towards the right, you're going to get every entity that is entirely contained in your selection. So if you want to do like this little one, you don't have to zoom way in and pick it. You can sort of create a selection that fully encompasses it. And that's in contrast to when you select towards the left, you get every entity that has any part of it in your selection. So and there's another trick I'll show where, so we need to delete and replace entities, but some of them sort of overlap. So let's say, like if I'm getting rid of this one, or let's check out one of these that overlaps. So how about this one, this one? So there's one that we need. So that line fully overlaps. So if we replace entity, we can't really pick the line without selecting the long one here. So what you can do is right click, select other, and then you get a choice of all the lines that overlap each other here. So then we can select the one we want. So those are the two tricks to deal with one that has more features going on. And I'll just skip doing the rest of this part and get back to the assembly. And if we change our layout sketch, say like that, everything updates. And our ribs are independent, they're different sizes, they have the same types of features, and we didn't have to make them from scratch. So I guess the advantage of this method is that a lot of the process is sort of automated. The disadvantage is, let's say you make your sort of parent rib and then copy 10 or so, and then do that process to make them all independent and updated. At that point, if you want to change them all, you're going to have to go and manually change the first one and the second one and the third one and the fourth one in each of their parts. There might be a better way to do this. I'm not sure, with maybe like configurations or something like that. If you know of a better method, let me know in the comments. But this is one way to do it, and it kind of forces you to keep your references clean, like your external references, just keep them as minimal as possible. Just bring in the entities that you need and nothing more. And yeah, so that's a way to reproduce many independent parts that have the same type of features, keep them independent. So that was copy with mates, make independent, replace entities. So just before getting to the subassembly ribs, I want to cover one last thing about these external ribs here. You probably noticed they don't have the cutouts for the stringers, and often we have like a square piece of wood along the leading edge. That would be like this aircraft. And so if we open up the subassembly of the wing extension here, the wingtips, we can see, for instance, the ribs have these cutouts. So how I would aim to do that for this one, what I would probably do is create all of these ribs as they are here with no cutouts for the stringers, and also the ribs that would be different for where the aileron is along the span. And once you have them in, then I would mate in stringers with maybe some assembly reference geometry, and those cuts on each of these ribs can come in from an assembly level cut or an assembly level after the mates, some intersect cuts onto your ribs. So here I'll open up sort of a intermediary stage of that. So this is like an intermediary stage where this is like an example where the stringers are in position. They're mated into position. We'll do another video on different ways to mate in stringers, and what's not done in this assembly is the cutouts aren't done, but we'll do another video where we cover some methods of mating in stringers and doing these cutouts. But for now, at this stage that we're at in the ribs we were producing in the other assembly, we'll keep them without any cutouts. So let's proceed on to the subassembly ribs. Let's say these ribs were subassemblies themselves. So instead of two sort of independent parts that are mated to the same position, we could have a subassembly rib, and each of our subassemblies, maybe we want to keep them, have the same type of parts and features, but change in size like these. So there's another way to do that. The way that I'm thinking of and know of is using pack&go as a sort of assembly copy with mates. So we'll check out that next. All right, let's take a look at the wing assembly where each rib is a subassembly. So we have here ribs 0, 1, 2, 3 through till 6. And each one of them is an assembly of a few parts. So 3 sheet metal parts and 2 wood parts. So if we just hide this skin and check out the assembly level geometry. So that's the planform geometry is what defines the shape of what constrains the shape of each of these rib subassemblies, and they're mated onto or pierced onto this wireframe planform with some geometric washout. So let's say in this wing we wanted to add another rib. So we can take a look at the planform geometry, and let's say we'll just create a plane for another rib. So just drag this maybe 15 inches. All right, so let's say our goal is to create another rib in this position here. So we'll call it rib new. Now, we're not going to use the copy with mates. Instead, we're going to pack&go the parent assemblies, sort of the original assembly that generated these. So if we take a look at in here, there's ribs, a folder for each rib subassembly, and they're filled up until 6, and then I made a 7th one too. 8, there's nothing in there yet. 9, nothing in. So let's say we'll put the 8th one in. And there's a parent which does not have an underscore. So if we open that subassembly, what we've got is this is the subassembly of the 5 parts. And the flange holes are just sort of reference holes at first, because if we change the size of this this rib, we might want to use different size flange holes at the end according to what tools we have, the flange forming tools. And so the geometry, this is what's defining the other 5 parts. This is sort of a independent part, and these 5 have external references to it. So if we take a look at the geometry, what we did here, so this is from a while back. This is from 2017 Concordia Aero design year, and we were trying to figure out how to do this. We wanted to make this parent assembly sort of parameterized in a way that you could change just a couple of points, like a point on a planform, and 2 points along this line can determine most of the rib's geometry, and then sort of these angles can determine where the spar is at. So we, in here, if we take a look at this point, we can just delete the fixed, and at that point the assembly is sort of stretchable. The sketch is sort of stretchable and you can rotate it, and I mean you can put it in any position and then exit the sketch, and the other 5 parts will update to that position. Up to a certain point, I mean, you can't make it too small. Like here, we have a 21-inch rib. If you start making it really small, it might get a bit sketchy. 7 inches still works. Obviously, these holes can't, if you start to have these holes touch the edges, you might have some rebuild issues. But so that's the concept, is that the origin is constrained. This one point, if we constrain it, if we fix it, it constrains everything else. And the way we did that, there might be a better way to do this, but we defined everything off of this chord length. So not through equations, because at that time, I mean, we didn't know a better way, but if you use equations, they don't update continuously. So, for instance, if you made one of these lines equal to like a quarter of the length of this line or whatever, it wouldn't update as you stretch or drag. It would try to rebuild and find a new solution as its current length once you finish dragging, and then it would try to find that solution. So I know that CATIA, I've seen the equations do continuously update in this sort of like stretchy way. So maybe there's a way to do that in SolidWorks if anybody knows how to do that. But the way we did this at that point in 2016 was to create one line that's a chord length equal. We make it equal to the chord length. And then each of these angles is an arctan of a fraction of that chord length. So maybe like a third chord length, a half chord length, 3/5 chord lengths, that type of thing. And then using sort of, if you select just that entity, you might have equals to certain portions of the sketch. Like, I don't know, if this is 30% chord, then the spar is at 30% chord, that type of thing. So, not sure if there's a better way to do that. This is the way we figured it out in 2016. And yeah, I remember taking a bit to figure out, but it ends up being, it works pretty well in the end. So the way you would use this parent assembly, so let's not save anything. So we have our plane for this new rib. So what we're going to do is go to the parent assembly, and we're going to put it into the 8th slot. So what we're going to do is go to the assembly itself and then pack and go. And we can do that actually in the assembly itself. So we do pack and go. And so here we have to make some details here. So we're definitely going to add a suffix. So I think it's _8. And well, let's check what the other ones were just to be consistent. So it's _H2 _0. Okay, yeah. So pack and go _8. So that updates the names. Now we're going to choose to put it in this folder. And this isn't really the intention of pack&go. So it kind of repeats the path. You can see it goes through here, and then we want it to end at this point. It kind of repeats the path over here. So let's just take the path and now we want to change this save to folder. We don't want it to generate such a long path in here, so I'm going to select replace in save to folder. So we don't want it to have the second beyond here. So yeah, we don't want it to have the second string of that. So if we put a slash at the end, now what we're going to do is put S1223 lib 8h slash and replace that with just 3 lib 8h, so that all that extra at the end can come off. So let's see if that works. Yeah, that worked. So it's putting it in the right folder. It's giving them the right names. So, and there'll be an independent, what pack&go is going to do is generate a new independent assembly and recreate all the references to itself without any references to this parent anymore. So if we save, it'll generate it. So if we open up that assembly, if we go to 8, it's here now. And this one's ready to, it's independent from the parent assembly, and it has a new name, and all these references are the same as the parent except with the new names pointing to the new assembly. So now we can insert that. So we'll take it from here. Yeah. Okay, so now we're going to recreate the mates. So we gotta check how these are mated. So front to front, I don't know why we made front as sort of the top plane at that point. Right to right, and then I guess top is what I would use the right plane as these days. So let's recreate that in here. This one is the one that is not mated in. So front to front. Top to right, I believe. Now we have this one's right with planform geometry one's new. So that's in position and constrained. I won't save it. Okay, so this one is ready to be put into position. You can see it doesn't fit in with the pattern of the other ones yet. So here we'll go into the geometry, edit it. This is the sketch, and I believe it's this point that we want to get rid of the fix. And so now we can sort of put it where we want it, and where that's going to be is this line, I believe. Yeah, that's the twisting of the washout. So we'll pierce it. That constrains it. Exit the sketch. And that's in position. So if we take a look here now, it fits. It's if we unhide the wing skins, let's hide these sketches for a second. So we can see it's in the right position. It's just barely brushing the skin. And there is one last thing. You can see sort of the spar sort of misaligned compared to the other ones. So that's because of the washout, because these ribs are rotating along the span. So I think I remember we did this as, if we go in here, I believe it's just this angle that we would get rid of, and then take this and make it collinear with some construction geometry like that. And then that lines it up. And probably the same thing for the aft spar. I don't remember, but there we go. Now it's lined up. So that was the concept. Might seem a bit weird, but it did save time. And I mean, this actually worked. We built this. This was a year that, I mean, I learned a ton this year. This team was really strong. I remember I was working on these ribs, and then Kyle Petrunik, a very, very good leader and very good builder and designer, and he showed me most of what was in this video, the copy with mates, and we both figured this out together. He showed me the pack and go, and remember we created this together. This assembly of these ribs, and then we built it. So let's just check that out pretty quick, just so I can show off what we did here. So here's the final CAD from that year, from 2016, 2017. I think in the final version we had the front spar perpendicular to the fuselage, perpendicular to the right plane. And that was making it easier to build. Now here's the first rib that we made, sort of a test block here to see how it would build up. So you would clamp the flat pattern sheet in between these two and just mallet it over with a rubber mallet, the flanges. So then we built a first iteration of the wing just to test it out, the build process and the structure of it. Here you can see the flanges. When there's a lot of curvature, you kind of need to just provide relief divots like these here. And so yeah, we built this test wing assembly, and here is this is Kyle's first iteration of like a center wing box, a fuse section of the aircraft. And yeah, we tested that out. And here's during the construction. So I should link, we had an official video that year, I think Naeem made it. I'll link that. And I have good memories of this construction. All the time in this team. This is some pretty intense build days down in BNX, Concordia University. So here's the wings coming together. That's me. I learned a lot from this time here, from all these people. Here's us testing the wing. So we're putting sandbags on top. That's the full-scale wing test. And here's it coming together completely. So the monocoat wasn't sticking to the aluminum, so we just kind of put some strips of balsa in between. But yeah, the wing box was pretty much on the OML of the structure. And here it is flying at the comp. You can see the wing box through the sun transparency here. So anyway, I hope you all learned something, and I'll make some more videos relating back to this year at this team. Just learned so much, and I was lucky to work in industry after that, so I've kind of been processing what I learned from that year and building on it. So yeah, thanks for watching, and keep an eye out for more videos.